Hi, let's continue looking at examples where we are using the Routh Hurwitz criterion to evaluate the stability of systems. And in this case, I'm taking a third order system, and the characteristic equation is shown on the screen. And let's try to evaluate the stability of the system. What would be the conditions on the coefficients A3, A2, A1 and A0 for the system to be stable? Okay, so we start by forming the Routh array, and the Routh array, the highest order here is S cube. So I'm going to write S cube and S square on the left hand side of my Routh array. Okay, actually if you want you can just fill this up. It's going to be s to the power 1 and s to the power 0. We won't be able to get the values for this column and this column yet, but the first two columns we have the values already, right? So we fill in a3, a2, a1 and a0, and that's all the values that we have. Now what is going to be the value that goes here? Okay, that is going to be, so it's going to be minus 1 over a2 determinant a3, a2, a1, a0, right? So and that, if we write it, if we evaluate this, what would we get? A2, and you get a3, a0 minus a2, a1. Okay, and you can write this as, if you want to just simplify it, it would come out to be a1 plus a3, a0 over a2. Sorry, this is going to be minus here, not plus. So this is going to be minus, right? So that's minus. So let's put this value in our Routh array. So we get a1 minus a3, a naught over a2. Okay, so what is the value that will go in the second column here at this position here? Now to get the value here, so let me just clear off my screen a bit so that we can just continue the evaluation. So okay, so that's ready. So what we want to do is, so to get the value at this position, we want to look at the values of, so our determinant is going to be formed of a3 and a2, right, which is the first column of the two rows above, and then the next column, but there are no values here in the next column. So this is the column of interest, the next column is here, and there are no values. So if there are no values, you can assume that the values are 0. Okay, so I'm just going to put 0 here temporarily, and therefore I can form the determinant 0 0, and that's going to be minus 1 over a2. And what is this value going to be? You can take a look. I'll just do the arithmetic, but it's going to be basically 0, because it's going to be a3 times 0 minus a2, sorry, times 0. Okay, that's supposed to be a times, okay, and that is equal to 0. So the value that goes here is basically 0. Okay, so let me erase this again and let's go to the next column. So what you would find is that uh, all the next elements, if you start to calculate, they are all going to be 0. Okay, so let's try to evaluate the value at this place. How do we evaluate the value at this place? We take the uh, two values from the first column of the Routh array, so a2 and this value. So let me just write it down here. Okay, so a2 and a1 minus a3 a naught divided by a2, and then I take the values the two values in the next column. So that's A0 and 0. So that's going to be A0 and 0. So that's going to form my determinant. And I say the value, it is going to be divided by what? 1 minus the value here, right? So it's A1 minus A3 A0 over A2. And I'll leave you to work this out, but what you would see is the answer is going to be here A0. Okay, so this is going to be A0. Okay, so now that we have evaluated our route array, we have reached the end of evaluation of our route array, right? Because if you look at the left hand side, the coefficient here is s to the power 0. You don't go beyond that because s to the power 0 is 1. That's the last row in the route array, and you have evaluated the first column of it. So we don't need all these values here. Even if you wanted to evaluate it, they're all going to be zeros, but in this case, we don't need them. Okay, so for stability, we want A3, A2, this particular quantity and A0 all to be of the same sign. Okay, so that's the condition for stability. So the condition for stability is that A3, A2, A0 and A1 minus A3, A0 over A2 are of the same sign, either positive or negative, but they have to be of the same sign.